Hey, ladies and gentlemen, happy Friday. Quick question. I've been thinking about maybe getting some kind of low-key chill music to be going in the background of these videos, but I don't know if it would be distracting to you guys. So let me get your opinion. If you think that would make these a little more enjoyable. I don't know, I was thinking some instrumental lo-fi stuff, or I don't know, something. Let me know if that would be something you're interested in, or if that's something that would really throw you off and would totally make it difficult to focus. So let's continue where we picked off. So yesterday we talked about permutations. Today we're going to talk about combinations, where order doesn't matter. All right? So let's get back to the familiarity of what exactly we're talking about. So yesterday we talked about permutations, and we had a little equation for it, where n was our stuff we had and r was our spots we had. Similar to if I had a lock, right? If I had a lock that was 4 digits, and let's say A, B, C, D were my options. So I could put A, B, C, or D here, A, B, C, D, or here, A, B, C, D, or here, A, B, C, D, or here. It would very much matter the order I put these in, right? Because the different orders would be different passwords. In other words, I could have A, B, C, D as a password. I could have A, C, B, D as a password. I could have A, C, or I'm sorry, A, C, D, B. I mean, you could just keep going. B, D, C, A. I could have B, C, D, A. BADC, and you could just keep going and keep going like this because the order very much matters. Well, the cool part about this is that's permutations. When it comes to combinations, combinations would say, dude, we only have one group here. It doesn't matter what order they're in. As long as we have all the pieces, that's a group. Sort of like if you had, let's say you have three friends, okay? If you have three friends and I say, all right, class, or I'm sorry, all right, friend, you can only bring three of your three friends with you. Would you care the order in which you have them coming with you? No, it doesn't matter because the three people are coming no matter what. It doesn't matter if you asked, who did we have yesterday? Ariel, um, Ariel, Dwayne, and Eduardo, or if you ask Eduardo, Dwayne, or an Ariel, the order doesn't matter. No matter what, they're all coming. So let's look at how combinations would work. This is our new equation, okay? Which at first was starting to remind me of a Christmas tree. So it's our normal permutation formula, except we're dividing the whole thing by r factorial. So n factorial divided by n minus r factorial, all that divided by r factorial. I'd recommend doing this piece first. So then all you have to deal with is a number divided by r factorial. That would make it a lot easier and faster. Pause if you need to finish writing. Let me show you an example, and it's going to be a short class today. It's Friday. I'll go easy on y'all. Here's my example of a combination. So let's say you want a free ticket for three people to join you to go to Disney World. Yay! Except you have six friends who all asked you, can I come? Can I come? And now you got to decide who's going to go with you. That's not going to go very well, I don't think. So the question is, how many different groups of people could you take? So you have six friends, right? Let's say friend one, friend two, friend three, friend four, friend five, and friend six. And you have three seats, right? You got three spots. So spot one, spot two, and spot three. So let's plug this into our new equation, which was n factorial over n minus r factorial all over r factorial. So remember the n is the number of things and the r is the number of spots. So I have 6 factorial here because I have 6 things. I got 6 people that are my options. So that would be 6, where do I write this? 6 factorial over n is 6 minus r is the amount of spots, and I have 3 spots, so 6 minus 3 factorial. That'll all be over r factorial. R is 3 spots, so 3 factorial. Let me simplify this just a little bit. So let's simplify the numerator. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. 6 minus 3 is 3, and 3 factorial is 3 times 2 times 1. That guy gets canceled out with that guy. 3, 2, 1, and 3, 2, 1 are canceled out. So now in the numerator, I just have 6 times 5 times 1. 6 times 5 times 4. I don't know why I said 1. Over. What's 3 factorial? That's 3 times 2 times 1. So now that I have my numerator simplified and my denominator simplified, now all I have to do is figure out what the answer is. So 6 times 5 times 4 over 3 times 2 times 1. 20 times 6, 120 divided by 6. What's 120 divided by 6? Da, 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 da. There are 20 different groups of people I could take with me. That's how you do a combination problem. It's just one extra step. So if I ask you to do a permutation, that means you're just going to do this top piece. If I ask you to do a combination, I just want you to do this bottom piece. Does that make sense? I hope it makes sense. Um, Next week, we're going to start talking what we're going to be doing for final exam world. Next week, we're going to finish the statistics section, which will be our last section. And I will give you more details about all that as we go. I'm thinking about doing a statistics project just so you guys have an extra test grade in there, just for kicks, something that would only take 1 week. More information will follow on Monday, okay? Just stay tuned. But bye for now. Have a great weekend.